Far away in the endless dark of space, a silent traveler drifts between the stars. It does not belong to our solar system. It does not orbit our sun, nor was it born from the same cloud of gas and dust that gave rise to the planets. Instead, it is a messenger from another world, a fragment of a distant cosmic story that has found its way into ours. This traveler has a name, 3I/Atlas, the third interstellar object ever discovered. But what secrets does it carry with it, and what can it tell us about the vast universe beyond our sun? The mystery begins with its arrival. The story of interstellar visitors started not too long ago, with the discovery of the famous Oumuamua in 2017. That strange, elongated object left scientists puzzled with its unusual shape and behavior. Just 2 years later, another visitor arrived, Comet 2I/Borisov, which revealed itself as a true comet from beyond the stars. And now, in the year 2024, astronomers have announced something extraordinary: the detection of yet another traveler, 3I/Atlas, silently passing through our neighborhood of the galaxy. But why are these discoveries so important, and what do they mean for us? Unlike planets or moons, interstellar visitors are not tied down to our solar system. They come from unknown star systems, carrying with them the chemical fingerprints of their origins. They are like bottles thrown into a cosmic ocean, drifting endlessly until they cross paths with curious eyes on Earth. Each one is a time capsule older than humanity itself, possibly older than our sun. And the idea that such a relic is passing by right now sparks both wonder and deep questions. Astronomers spotted 3I/Atlas using the Atlas Survey System, a network of telescopes in Hawaii designed to scan the skies for incoming asteroids. At first, it looked like just another small, icy object. But as researchers traced its orbit, something unusual appeared. Instead of looping around the sun like a normal comet, its trajectory was hyperbolic, an open-ended path. This meant it was not bound to our solar system at all. It was just visiting, destined to leave and never return. Imagine, for a moment, the journey this object must have taken. Perhaps it was ejected billions of years ago from a young star system far away, cast out by the gravitational tug of a giant planet. It could have wandered alone through the cold void for countless ages, until by chance, it drifted close enough to be noticed by us. This means every interstellar visitor is more than just a rock. It is a witness to the birth and death of alien worlds. One of the most exciting things about 3I/Atlas is that it might help solve the puzzle left behind by Oumuamua. That first visitor had so many mysteries. Was it a comet without a tail? Was it a shard of a shattered planet? Or was it something stranger altogether? Scientists still don't fully agree. But now, with Atlas, researchers have the chance to compare and see what interstellar objects really look like. Could Atlas finally give us the answers Oumuamua never did? Another intriguing question is the chemistry of 3I/Atlas. If astronomers can analyze the gases it releases as it warms near the sun, they may detect ices and molecules that are different from those found in our own comets. That would be a direct clue about how other planetary systems formed. Just as a single fossil can tell us about an entire ancient ecosystem, A single interstellar object could reveal secrets about alien chemistry, and that possibility keeps scientists watching very closely. But there is also a deeper mystery hidden in these discoveries. Why are we suddenly detecting interstellar visitors now? The sky has always been full of them, passing silently, unseen. For billions of years, countless objects must have slipped through our solar system unnoticed. Yet in just a few short years, we have already found 3. Does this mean our technology has finally become sensitive enough to catch them? Or could it mean that something unusual is happening in our corner of the galaxy right now? The timing raises questions that we are only beginning to ask. Think of it this way. If 3 visitors have appeared in just a few years, how many more are out there waiting? How many secrets have already slipped past us in the dark? Astronomers now believe that interstellar objects may be far more common than we once imagined. Perhaps billions of them drifting through the Milky Way. Each one is a story waiting to be told, and Atlas is just the newest chapter. But what kind of story does this particular visitor bring? For now, 3I/Atlas remains faint and distant. Telescopes are working hard to track its movement, gather data, and catch every possible glimpse before it fades back into the void. Every observation counts because once it's gone, it will be gone forever. There will be no second chance. The cosmic messenger will continue its silent journey into the unknown, carrying with it answers we might never uncover. And that fleeting nature makes its presence all the more precious. When scientists first confirmed that 3I/Atlas was not bound to the sun, a wave of excitement rippled through the astronomical community. This wasn't just another icy rock wandering within the Kuiper Belt. It was a traveler from another star system. Imagine for a moment. A piece of material billions of years old, formed in a completely different corner of the galaxy, now flying past us for the very first time. It's as if the universe has thrown us a message in a bottle across the cosmic ocean. But what secrets does this bottle really contain? The speed of 3I/Atlas is one of the biggest clues to its interstellar origin. Unlike comets native to our solar system, which follow elliptical paths around the sun, Atlas entered on a hyperbolic trajectory. Its velocity, around 26 kilometers per second relative to the sun, is simply too fast for it to be captured by our star's gravity. This high speed means it will never return. It's a one-time visitor, here for a brief glance before disappearing forever. But if it's leaving us so quickly, what can we learn before it's gone? Telescopes around the world scrambled to point at this mysterious guest. From Hawaii to Chile, observatories began tracking its movement, hoping to gather as much data as possible before it faded into the darkness. Astronomers measured its brightness, looking for signs of gas or dust escaping its surface. Was it active like a comet, or quiet and inert like a simple asteroid? These early observations revealed faint signs of outgassing, meaning it was indeed shedding material, a sign that it carried volatile ices. But what kind of ices were hidden inside, and what story could they tell about its birthplace? One of the most intriguing aspects of 3I/Atlas is the question of its composition. Comets from our own solar system often contain water ice, carbon dioxide, and complex organic molecules, the same building blocks that may have seeded life on Earth. If Atlas carries similar ingredients, it means other star systems could also be rich in the chemistry of life. Just imagine a frozen fragment of an alien world, carrying within it the raw materials that might one day spark biology elsewhere. But could Atlas truly be a messenger of life from the stars? The brightness of Atlas puzzled astronomers as well. Unlike 2I/Borisov, which was small and dim, Atlas seemed unusually bright. At first, some wondered if it might be significantly larger, perhaps several kilometers across. But brightness can be deceiving. It depends not only on size, but also on how much dust and gas a comet releases as it warms. If Atlas was breaking apart, its brightness would increase dramatically, making it look far more impressive than it really was. So was Atlas a giant among comets, or simply a fragile visitor falling apart before our eyes? The name 3I/Atlas itself carries meaning. 3I marks it as the third interstellar object ever recorded. Atlas comes from the Asteroid Terrestrial Impact Last Alert System, the telescope that discovered it in Hawaii. But the word Atlas also stirs the imagination. It reminds us of the mythological titan who held up the heavens, a fitting name for a comet carrying cosmic secrets from beyond. Could it be that this Atlas, too, is carrying the weight of interstellar knowledge on its icy shoulders? What makes 3I/Atlas even more fascinating is its comparison to the two earlier visitors. Oumuamua, the first, baffled scientists with its strange shape and unexplained acceleration. Borisov, the second, looked more like a normal comet, but its composition hinted at exotic origins. Now, with Atlas, we have a third data point, a chance to begin comparing and contrasting interstellar objects. Each one is a puzzle piece, slowly revealing the picture of how planetary systems across the galaxy are born and evolve. But what unique piece of the puzzle does Atlas bring us? Some researchers propose that Atlas might not have been a single solid body at all, but rather a fragmenting comet, shedding pieces as it traveled through the solar system. Observations suggested it may have split apart into smaller chunks, just as some native comets like Shoemaker, Levy 9 have done. This idea is both thrilling and tragic. Thrilling because we get to witness the raw, destructive power of cosmic forces. Tragic because a crumbling Atlas might rob us of the chance to study a pristine interstellar relic. Was this breakup the comet's way of hiding its most precious secrets, or revealing them to us in pieces? The distance of 3I/Atlas from Earth made studying it even more challenging. Unlike Oumuamua, which passed relatively close, Atlas never came anywhere near us. It remained far away, visible only to large telescopes. That meant data was limited, and every observation carried enormous weight. Astronomers knew they might not get another interstellar visitor for decades, or perhaps centuries. Each night spent studying Atlas was like peering through a tiny window that would soon slam shut. Would we be able to glimpse enough before that window closed forever? Even as Atlas continued its journey outward, interest only grew. Papers were written, theories debated, and simulations run to estimate where it might have come from. Was it ejected from a young planetary system? Could it have been knocked loose during the violent formation of distant worlds? Each possibility painted a different picture of its origin story. And with every question, Atlas reminded us of the vast, unknown variety of star systems scattered across the Milky Way. But just how far had this frozen traveler journeyed to find us? Imagine the vastness of our galaxy, the Milky Way, a swirling collection of hundreds of billions of stars. Each of those stars could have its own family of planets, moons, and wandering debris. Somewhere in that ocean of light, something once stirred. Perhaps a star tugged at its planets too strongly, flinging a lonely fragment into the endless dark. Billions of years later, that fragment may have arrived here as 3I/Atlas. But what if its story began far more dramatically? Scientists propose one possibility, that 3I/Atlas is the shattered remnant of a planet torn apart near its parent star. When stars age and expand into red giants, they can swallow or disrupt nearby worlds. If 3I/Atlas was once part of such a world, then what we see is the silent grave marker of a cosmic catastrophe. Does that mean we are gazing at the ashes of an alien planet? Another theory suggests that 3I/Atlas could have been born in the cold outskirts of another star system. Far from the warmth of suns, countless icy bodies drift silently, waiting for a gravitational nudge to free them. A passing star, or even the ripple of a galactic tide, might have been enough to eject such an object into interstellar space. Over millions of years, this icy traveler could have wandered aimlessly until chance carried it into our solar system. But what if this was not mere chance, but part of a grander journey? Consider the violence of young star systems. In their early days, newborn stars are surrounded by swirling disks of gas, dust, and ice. Within those disks, planets form, migrate, and collide. During this chaotic time, countless fragments are scattered outward. Some remain bound to their suns, while others are flung so far they escape entirely. Could 3I/Atlas be one of those ancient exiles, a castaway from the chaotic birth of an alien world? If so, then its very presence tells us about the childhood of distant stars. But then, there is an even more intriguing possibility. What if 3I/Atlas was not created by natural forces alone? Some scientists, when considering earlier interstellar visitors like Oumuamua, speculated whether they could be fragments of alien technology. Perhaps sails, probes, or debris left behind by civilizations we cannot yet imagine. While most astronomers remain cautious, the idea lingers. Interstellar space may carry not only the rubble of stars, but the relics of minds. Could 3I/Atlas be one such relic, drifting silently through eternity? The mystery deepens when we examine its brightness. Unlike Oumuamua, which reflected sunlight in strange ways, 3I/Atlas appeared more like a traditional comet, dusty, hazy, and shedding material as it neared the sun. This makes it likely that it is natural, an icy body not unlike the comets of our own solar system. Yet even comets carry secrets. Within their frozen shells lie chemical records from the earliest days of planetary birth. If 3I/Atlas formed around another star, then inside it may be alien chemistry, frozen fingerprints of a world we will never see. And isn't it astonishing to think that a piece of another star system may have brushed so close to us? There is also the possibility that 3I/Atlas is a survivor of something even greater, an ancient supernova. When massive stars explode, they scatter planets, asteroids, and debris like sparks from a fire. Some of those fragments are cast far across the galaxy, carrying with them the memory of a star's death. Could 3I/Atlas be one such spark, launched from the ruins of a star that no longer exists? If so, then we may have witnessed not just a traveler, but a messenger from a long-dead sun. Every possibility we consider, whether alien technology, cometary exile, planetary shard, or stellar ember, reminds us of one truth: interstellar objects are storytellers. They arrive carrying fragments of histories written light years away. But the cruel irony is that they never stay long enough for us to read their full story. 3I/Atlas came, shimmered briefly under our gaze, and then drifted back into the cosmic dark. But where does it go next? And what stories will it whisper to the stars it passes? The origins of 3I/Atlas may forever remain uncertain. Yet even its uncertainty has value. By studying these visitors, astronomers refine their tools, sharpen their predictions, and prepare for the next one. Each discovery pushes the boundaries of our cosmic understanding. And so, while 3I/Atlas has vanished, its memory fuels a deeper hunger. The desire to know where these voyagers are born and how often they pass by. Which leads us to wonder, was 3I/Atlas the last interstellar messenger we will see, or merely one among countless more to come? Detecting an interstellar visitor is a little like spotting a single firefly in a vast, dark forest. The sky is enormous, the number of stars uncountable, and yet scientists rely on a careful blend of patience, precision, and technology to capture these fleeting travelers. When 3I/Atlas was first noticed, it was not because it announced itself, but because wide-field telescopes constantly scan the heavens, taking image after image, night after night, searching for anything that doesn't quite belong. These surveys are humanity's watchtowers in the cosmic night. But what happens when one strange flicker on those images suddenly reveals itself to be something from another star? The first tools that catch interstellar objects are usually sky surveys, automated telescopes designed not to focus on one star or one planet, but to sweep across large areas of space. The Atlas system in Hawaii, short for Asteroid Terrestrial Impact Last Alert System, was designed to spot near-Earth asteroids that might pose a danger to our planet. Ironically, it ended up detecting something far more exotic: a visitor from another star system. This is the beauty of scientific instruments. They sometimes find things they weren't even built to look for. And in that serendipity lies the thrill of discovery. Once a suspicious object is detected, the real work begins. Astronomers around the world turn their telescopes toward the moving point of light to confirm its path. This process is called astrometry, the careful measurement of position and movement. Each observation adds a new data point, and those data points together form a map of the object's trajectory. For 3I/Atlas, those measurements quickly revealed something extraordinary. It wasn't bound by the gravity of our sun. Its path was hyperbolic, meaning it was just passing through. And suddenly, scientists realized they had another interstellar guest on their hands. But catching these objects is a race against time. They move fast, faster than almost anything else in the solar system, and the window for observation is often just weeks or months before they fade into the darkness again. This urgency transforms astronomy into a global collaboration. Observatories in different countries, from the Americas to Europe to Asia, coordinate to track the visitor. Data is shared, trajectories refined, and every precious photon of light captured before it's gone. It's like trying to study a bird in flight while it disappears over the horizon, except the bird is traveling at tens of kilometers per second. Different instruments reveal different secrets. Optical telescopes can measure brightness and estimate size. Spectrographs, devices that split light into a rainbow of colors, allow scientists to determine what the object is made of. For 3I/Atlas, this was key. By analyzing its light, astronomers could estimate its composition, hinting at whether it was icy, rocky, or a mix of both. These details matter because they connect the object to the story of how it formed in its original star system. In other words, a few faint photons of light can tell the tale of an alien world billions of years away. But telescopes on Earth have limits. The atmosphere blurs and blocks some light, and many interstellar visitors are faint, almost ghost-like. That's where space-based telescopes come in. Instruments like the Hubble Space Telescope or the James Webb Space Telescope can study these wanderers without the interference of Earth's atmosphere. In fact, astronomers dream of one day having a dedicated interstellar object observatory in space, ready to catch the next 3I/Atlas before it vanishes. Because the truth is, we are still only scratching the surface of what these cosmic visitors can teach us. Even with today's tools, every discovery comes with uncertainty. Interstellar visitors don't linger. They don't wait for us to gather perfect data. This means scientists must often work with incomplete information, filling in the gaps with simulations and models. For example, computer programs can recreate the object's trajectory backward in time, trying to guess which distant star system it might have come from. Though we may never know for certain, even narrowing the possibilities is enough to deepen our understanding of the galaxy. Each guess is another breadcrumb in the trail of cosmic migration. There's also the dream of something more daring, actually sending a spacecraft to intercept an interstellar visitor. For now, this is still only a concept, but missions like the proposed Comet Interceptor by the European Space Agency are designed with flexibility in mind. Such missions would wait in space, ready to launch toward a passing comet, or, if luck allows, an interstellar traveler. Imagine the first close-up images of a rock or an icy fragment from another star system. That moment would redefine planetary science forever. The question is, will we be ready in time for the next one? Until then, scientists rely on the careful work of observation, collaboration, and analysis. Each tool, from a ground-based telescope to a spaceborne observatory, is like an instrument in a great symphony, all working together to capture the faint music of a visitor from beyond. And with each note recorded, humanity steps a little closer to understanding not just the traveler itself, but the vastness of the galaxy it came from. Because every fleeting object is more than a mystery, it's a messenger from the stars. When we talk about 3I/Atlas, it's easy to get lost in the numbers, the orbits, and the telescope data. But behind all the science lies a deeper truth. Interstellar visitors like this one remind us that we are not isolated. Our solar system is not an island, cut off from the rest of the cosmos. Instead, it's a crossroads, a place where material from distant suns, ancient worlds, and perhaps even long-gone civilizations can drift through. The arrival of 3I/Atlas is more than a scientific event. It's a cosmic reminder that we are part of something far larger than ourselves. And with every such visitor, we are forced to ask a haunting question. What secrets might these travelers carry? If interstellar visitors come from worlds we've never seen, then they may hold the raw ingredients of life itself. Scientists believe that comets are like time capsules, preserving ices and organic molecules from the earliest days of their home systems. When we examine comets within our own solar system, we find complex chemistry, carbon chains, amino acid precursors, and other ingredients of biology. If that's true for our local comets, imagine what an interstellar one could reveal. Perhaps in its frozen heart, 3I/Atlas carries molecules forged under a different star, in a different nursery of creation. Perhaps it holds chemical fingerprints of processes we've never witnessed. The possibility is staggering. Interstellar comets may be carriers of alien chemistry, drifting through space like seeds searching for fertile ground. What if life itself, our life, owes its beginnings to travelers like these? This idea has a name: panspermia. It's the hypothesis that life, or at least the raw building blocks of life, can spread across the universe by hitching rides on asteroids, comets, or interstellar dust. If this is true, then visitors like 3I/Atlas aren't just curiosities. They could be messengers linking distant worlds through chemistry and perhaps even biology. Imagine the poetry of it. A comet born around a faraway star, carrying organic matter across the dark sea of space, only to pass through our skies billions of years later. Perhaps such a comet once seeded Earth, sparking the chain of events that led to oceans, forests, animals, and us. The thought is dizzying. If life can travel the stars, then maybe we are all connected in ways we cannot yet see. Even if 3I/Atlas doesn't carry life, its existence still changes how we think about the cosmos. It tells us that star systems are not closed boxes. They exchange material, just as rivers exchange water with the sea. Over billions of years, countless fragments are ejected from forming worlds and scattered across the galaxy. Some are captured, some are destroyed, and some become wanderers, like Atlas, crossing vast gulfs until chance leads them past new suns. This galactic mixing means that what we think of as ours is not truly ours at all. The atoms in your body may once have belonged to a star far away. The dust in our solar system may have origins older than the sun itself. And with every interstellar comet we glimpse, we are reminded of this shared ancestry. If the universe shares its matter so freely, perhaps it shares its destiny too. For astronomers, 3I/Atlas is also a call to action. We've only detected 3 interstellar visitors so far. Oumuamua in 2017, Borisov in 2019, and Atlas in 2024. That's just a tiny fraction of the countless wanderers out there. The challenge is to see them in time, before they fade into the void again. New projects are rising to meet this challenge, like the Vera C. Rubin Observatory in Chile, which will soon scan the entire night sky with unprecedented sensitivity. Scientists hope it will uncover dozens, maybe hundreds of interstellar objects in the coming decades. Each one will be a new opportunity, a new messenger from the deep. The next interstellar visitor could already be on its way, invisible for now, but destined to one day light up our skies. What 3I/Atlas ultimately gives us is perspective. We often imagine humanity as small, fragile, and alone on our pale blue dot. But when a traveler from another star graces our skies, it tells us otherwise. It tells us that the galaxy is alive with motion, exchange, and mystery. That even in the coldest reaches of space, there are connections waiting to be found. That we are not looking out into an empty void, but into a cosmic ocean filled with countless ships, some visible, some forever unseen. If comets are the messengers, what is the message they're carrying? Perhaps the message is this: that we are part of a greater whole, that the story of Earth is linked to the story of other stars, that the matter which makes us human is not confined to one corner of the galaxy, but belongs to the cosmos itself. When 3I/Atlas fades into the distance and is lost to the dark, it leaves behind not just data points on a graph, but wonder. Wonder that keeps us searching, keeps us asking questions, keeps us awake under the stars at night, listening for the next visitor. And so, as we close this journey, let's hold on to that sense of wonder. 3I/Atlas may vanish, but the meaning it carries does not. It tells us that we are explorers by nature, always seeking to understand our place in the vastness. It reminds us that even the smallest object, a comet of ice and dust, can open a window to infinity, and it whispers to us softly that maybe, just maybe, the universe is not silent at all. If 3I/Atlas is only the third interstellar visitor we've seen, how many more are still out there, waiting to write the next chapter of the story of the stars?